Okay, here we are with target 20 for Algebra 2. This continues in Unit 3 on radical functions. So today we are going to take a look at graphing square root and cube root functions. In this first part of target 20, we're going to focus on square root functions. So if we begin with the parent function of a square root, using the most basic of square root functions, f of x equals the square root of x. What we see is that the domain for this is only values of x greater than or equal to 0. Okay, that's the domain. And the range, we only end up also with values greater than or equal to 0 for y. Now, every square root function is going to have the same basic shape of having a starting point and then curving up, okay, and kind of leveling off. It's always going to continue going up, but it seems to almost level off, okay, even though it will never actually not increase. It will continue to increase forever in that direction. But it starts going up steeper at first, okay, and then less and less steep as we get further out. All right, so that's what every square root function is going to look like. It's going to have that same basic shape of that kind of a, if you think about it, it's almost like it's half of a u, which should make sense because the square root is the inverse of a square, right? And we all know that when you square something, right, if we graph a square function, okay, it looks like this. Okay, so it makes sense that the square root function is just going to be the positive side of that and flipped on its side. All right, now if we want to graph a general square root functions of the form y equals a times the square root of x minus h plus k, there are 5 steps. Okay, really only 3 steps. The last 2 steps are determining the domain and range. So the first step is going to be to graph the point hk. Okay, that's going to be that starting point. Okay, the starting point of every square root function. All right, then the second point that you want to graph is basically you move 1 to the right of h and then up a units from k, or down if a is a negative number. So we graph this point, h plus 1, k plus a. X coordinate is h plus 1, so just 1 to the right of whatever h was. And then k plus a, so whatever your k value was, you move up a units, okay, or down a if it's negative. And then step 3, okay, draw a curve from hk through the other point, okay, similar to the parent function. So again, we draw hk here, okay, and then go over 1 unit to the right. Okay, so go 1 unit to the right and then up a units so that your other point is h plus 1, k plus a, and then you draw that kind of half a sideways u through those points. Now, determining your domain and range, okay, the domain is always going to be based on h. So if you look at h, that will be the low point of your domain, and infinity will be the high point. So your domain will always go from h to infinity. So you should always write your domain in that manner. Now the range is a little bit trickier because it depends on what your value of a is. If a is greater than 0, so if you have a positive value of a, then your range will be from k to infinity. So it starts at k and goes to infinity. Right, which makes sense because if you're opening up, right, like this one, okay, if we're opening up, then our range will be, okay, from whatever k is, right, up. But if a is less than 0, okay, then what's going to happen is if your a is negative, then when you plot hk and you plot h plus 1 k plus a, right, you're going to go down, right, because a is negative. So your graph would look like this. So now your range is going to be from k down to negative infinity. So the way we write that is from negative infinity to k. And that's going to be if a is less than 0. So if you have a negative a. So again, what would this point be over here? This would be h plus 1 and k minus a, because a is negative. All right, so let's take a look at some examples now of how to graph square root functions. So the first one we have here is y equals -2 times the square root of x minus 3 plus 2. So remember that it's y equals a times the square root of x minus h, right? So h is whatever's being subtracted from x, and then plus k. So in this, this square root function, okay, a is going to equal -2. Okay, h is going to be 3 because that's subtracted from x. And k is going to be 2. All right, so our first step is to plot hk, which will be 3, 2. So if we go 3 to the right and up 2, here's our hk. And second step then is to plot h plus 1. So if we add 1 to 3, we'd be at 4. And then k plus a. So k is 2, okay, a is -2, so 2 plus -2 is 0. So 4, 0 is right here. So what we can see then is this is going to go open down. So our graph, right, step 3, okay, is draw the graph. So we're going to start at our hk, and we're going to swing down through that other point, okay, like that. And there's the graph. Now, the other piece then is we need the domain and range. Okay, so the domain is always the value of h, which is 3 to infinity. And then the range, since k is negative, or I'm sorry, since a is negative, we're going to go from negative infinity to k, like that, for our range. All right, here's the next example. Why don't you try it? Pause the video. Once you have your answer, okay, then you can restart and see if you got it correctly. All right, so for this one, we have a is going to be -4. Now, notice that there is nothing subtracted from x under the square root. That means that h is equal to 0, and then k is equal to 2. So step 1 is to plot hk. So that's going to be 0, 2. So we go 0 to the right and up 2. So there's your starting point of your graph. Second step then is to plot h plus 1. So we go over to 1. And then k plus a. So if we add k and a together, we get -2. So if we go over 1, down 2, okay, there's your second point. Okay, and what we can see from this now is that it's opening down. So we come from our starting point and swing down through this. Okay. Now, what we should notice is that as a becomes a bigger number, whether it be positive or negative, okay, that starts out steeper. Okay. If it's a smaller number for a, it starts out more level. All right, so then 3, we draw the graph. We did that already. Okay, so draw a graph. Already done. Okay, and then we need the domain and the range. So the domain is always h to infinity. So h is 0, so we go 0 to infinity for the domain. And for the range, again, we're opening down, so it starts at negative infinity and works its way up to k. So we have that for the range. All right, one more example. Again, give this one a try on your own, pause the video, and when you're ready, you can restart. All right, this time our A is going to be 1/2. Okay, our h, which is again the number being subtracted from x, is equal to 3, and then the k is -1. So first step is to plot hk. So that would be 3, -1. So that's 3 to the right, down 1. Here's our starting point. Step 2 is to plot h plus 1, which would be 4, and then k plus a. So -1 plus 1/2 is -1/2. So plotting that point, 4, -1/2 would be here. So as I said before, when a becomes a smaller number, like 1/2, we start out a lot shallower. So it goes like this. And there's your graph. So that was step 3, draw a graph. Okay, finally the domain and the range. Okay, domain is always from h to infinity, so 3 to infinity. And then the range, okay, now we open up because a is positive, so now we're going to go from k, which is -1, to infinity for the range. All right, so you got your 3-step process. Plot hk, okay, plot h plus 1, k plus a, and then draw your graph. Okay, domain is always from h to infinity. Okay, range can either be from k to infinity or from -infinity to k. All right, check back tomorrow for the second part of target 20, okay, which is on cube roots.